Welcome. In this tutorial, we'll check if a given positive integer can be expressed as a sum of two or more consecutive positive integers. We'll use a clever bitwise trick to determine the answer without actually summing all possible combinations. This approach is both efficient and mathematically elegant. Let's see how it works. Some numbers like 10 and 33 can be broken into sums of consecutive integers. Others like 8 cannot. This interesting fact here is that powers of 2 are exactly the numbers that cannot be expressed this way. We'll use that property in our code. We use the expression n and n minus 1 to check if a number is a power of 2. If the result is 0, it is a power of 2 and cannot be expressed as a sum of consecutive numbers. If the result is not 0, then it can be expressed this way. This works because powers of 2 have only one bit set in binary form. The bitwise AND operation here checks if the number has more than one bit set in binary form. If only one bit is set, it is a power of 2. So, the sum of the consecutive integers is not possible. Otherwise, the representation exists. Here's how the program works for a few examples. For 33 and 10, the function returns true. For 8, the function returns false because it is a power of 2. This problem is popular in algorithm interviews because it combines number theory with bitwise logic. It is also a nice example for teaching how powers of 2 work in binary. In this tutorial, we've learned that powers of 2 are the only positive integers that cannot be expressed as the sum of consecutive numbers. By using a simple bitwise check, we've created an efficient solution. This is the great blend of math insight and coding efficiency. Thank you for watching. If you enjoyed this video, please make sure to like, share, and subscribe for more JavaScript tutorials. I'll see you in the next one.